Bienvenidos, Ushamdi, and welcome. CTS231, Section 841 students for the first 8-week term in the fall 2017 semester at Anne Arundel Community College. This evening's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 3.3.1.5, where we're going to be configuring PVST, PVST+, and we'll actually talk about what the difference is between PVST that does not have the plus sign and PVST+. So let's go ahead and dive into the activity. As you can see, it's a very basic setup here. We've got 3 switches, switch 1, 2, and 3, and we're kind of set up in a access layer, distribution layer kind of a topology here. We've got 3 PCs that we're going to be working with to bring online. And before we dive in, let's talk a little bit. You can see up here it says configuring PVST+. And so real briefly, I want to discuss what the different versions of spanning tree are and how we ended up where we're at today. And we talked about this in class. And so this is actually going to be pretty important. And so I'll clear that out. I was using that a long time ago. So initially, Radia Perlman, when she was working at Digital Equipment Corporation, or DEC, came up with the original version of the spanning tree protocol. And what happened, and I'll just put RP for Radia Perlman. And what happened was this got sent to the IEEE, and the IEEE standardized that version, and they called it IEEE's 802.1D, and it was 1998. And so it was Radia Perlman who initially came up with the idea of creating a protocol that would allow for loop freedom within your layer 2 domain. And so again, the IEEE standardized this as 802.1D in 1998. Now, at the same time, Cisco took a look at this and said, well, we think this is great, but one of the things about the IEEE 802.1D from 1998 standard, and we'll call it the original 802.1D standard, is that the entire spanning tree topology was a single instance of spanning tree. So I'll just put one instance of spanning tree, right? And that was for the entire network. So irrespective of how large your layer 2 network was, it was a single instance of spanning tree. And so Cisco looked at this, and Cisco said, well, we think that's great, but we've got a concern, because if you have a access layer switch and it's connected up here to a distribution layer switch, and these guys are connected like this, and we'll say distro 1 and distro 2, if spanning tree is going to block one of these links, and we'll say it's this one here, or I should say port, if it's going to block one of these ports, and we'll say that it's blocking the access layer port here. In other words, no traffic is passing over this link because that interface is blocking. And we need to have it blocked because remember that Ethernet frames do not have a TTL. In other words, they don't have a time to live. So a frame, if it's circulating through your layer 2 domain, is never going to expire itself out like an IP packet would, which typically has the TTL of 255. And as it goes each hop, it's getting decremented. Well, with Ethernet frames at layer 2, that does not happen. So if a frame doesn't make it to its destination, it can simply circle around without spanning tree. So spanning tree is blocking this link, and so Cisco said, well, I think that's great, but we're forcing everything to go that direction. All of our traffic, if we had a bunch of hosts down here, right, they're all going to be forced to go either to the left or to the right, depending on which side, which uplink is going to be blocked. You're going to have to make a choice. So Cisco said, we have a better idea. and I'll write this here as Cisco proprietary, and they said, we're going to do per VLAN spanning tree. And we're also going to do this thing called per VLAN spanning tree plus. And we'll talk about what this means here in 2 seconds. But the key right now is the P and the V, per VLAN, because Cisco realized that I could send VLANs 10 and 20 this way, and if I'm doing per VLAN spanning tree, I can send VLANs 30 and 50 this way, so that this link right here is not simply sitting there unutilized, that we're actually utilizing both links. And so this you can look at as a rudimentary form, and really one of the few forms of layer 2 traffic engineering. So when you set your topology up, and we'll see what that looks like over here in the packet tracer activity, when you set your environment up, if you've got multiple hosts from multiple VLANs and you want to load balance that traffic from a layer 2 perspective, we can use per VLAN spanning tree to do that. And that was the benefit of Cisco's PVST and PVST Plus. And all they did was they took the original standard and they added in the Cisco secret sauce, right? Which allowed it to be a per VLAN protocol. Now, they also added in some additional features to the PVST, PVST Plus. And we're going to look at 2 of those this evening. Portfast is the first one, and Bpdu guard is the second one. I'll talk about root guard, Bpdu filter, uplink fast, backbone fast. We'll talk about those because those are also all part of the original 802.1d adapted standard that Cisco took and implemented and called PVST, PVST Plus, right? So per VLAN. Now, why no plus sign on the first one, and what's the plus sign mean over here? Well, we need to remember that Cisco had its own proprietary trunking encapsulation, which on equipment today, on the latest and greatest equipment, the 3650 or the 3850, and on the 2960s, again, the more recent models, ISL or inter-switch link as a trunking encapsulation is not even an option. But back in 1998 and around the time that this work was being done, it was. And so when you say PVST, that implies that you're doing ISL trunking. And so then PVST Plus, Cisco came out with that to ensure that they were going to be supporting 802.1q, which actually has outlived and sort of killed off ISL. And so on 2960s or 3850s or 3650s, the more recent hardware from Cisco in the switching lines, ISL isn't even an option. 802.1q is the default and the only trunking encapsulation option. In fact, we saw that in our lab on Tuesday evening when, by mistake on some of the 2960s, individuals were typing switch port trunk encap.1q and you would get an error back because it's already set to 802.1q. That's the default. And so that's why there's no plus sign here, and then the plus represented that you were doing 802.1q, which is why in this activity we have 2960s. And again, going forward, ISL is legacy. It is deprecated. It should not be used. If it's in your environment, you should probably be looking to upgrade. Excuse me. So here's how I'm going to do this. When I refer to the original standard, I will say the original 802.1d, and that would mean the 1998 version. When I say PVST Plus, I'm referring to Cisco's proprietary implementation And again, the adaptation, they basically took the standard and said, yeah, the standard's great, but it's got this single instance thing here. There's no concept of Portfast, so we have to wait through the listening and the learning stage, and we'd like the ports to come up quicker. So they implemented the Spanning Tree Toolkit. So I'll say Spanning Tree STTK, the Spanning Tree Toolkit, right? And that gave us Portfast and Bpdu guard, among other things. BPD UGuard. I'll just abbreviate it there. All right. And so things were great, right? But as we discussed in class, the convergence time for PVST Plus, as well as for the original 802.1d standard, was horrific, right? Where you could end up waiting 45 to 60 seconds waiting for the listening, waiting for the learning, waiting for the max age timer to expire if, for whatever reason, a node lost communication or contact with the root bridge. And so you're going to have to wait for that max age timer to expire and the topology change notifications to fire out. And so, again, it was just substandard. So it was right around, and I want to say it was around 2004. It was adapted in 2004, but irrespective of the date, we know it's part of the 802.1d 2004, but we're going to say Rapid Spanning Tree Protocol, right? And again, the key being the R. So the IEEE came out and they said, yeah, you know what? The original version of 802.1d, it's not converging the way we'd like it to, and always looking to improve things. The industry got together and said, great, let's do rapid spanning tree protocol. And in some cases, if your architecture is constructed properly, you can end up with sub-second convergence. And they called this 802.1W. And that was the rapid spanning tree protocol. And again, remember, this is the IEEE standard, 802.1W. And again, it was a single instance for your entire layer 2 domain. Single spanning tree protocol, a single rapid spanning tree protocol instance for everything. Again, just like we saw up here with the standard for the original 802.1d. So Cisco said, you know what, that's great. And they actually, in this RSTP, they incorporated the Cisco features from the toolkit that are no longer in use because rapid spanning tree protocol, you should be using Cisco's version, and we'll talk about that in a second. But they implemented, I'll put in here, uplink fast, and backbone fast. I'll just say BBF and backbone fast. So these two Cisco toolkit features that were used to optimize Cisco's implementation of the original 802.1d standard were rolled into the rapid spanning tree protocol 802.1w standard. But then Cisco said again, hey, you know, it's great that we've got these features that you've rolled in that we were working on, but it's not per Vlan. So we are still stuck with the issue that we can't load balance like we could do up here, right? Again, it's a single instance of spanning tree for every single Vlan, right? So there's going to be a port that's blocked somewhere in this topology, and there will be no traffic floating across that link. There'll be no data traffic floating across that link. So Cisco said, and here's where I started to explain how things became so confusing. And we'll see on the command, in fact, I'll pull it up here in a second, you'll see on the command line the reason why. So Cisco said, that's great. Well, we're going to do rapid per VLAN spanning tree, or RPVST, if it's ISL is your trunking encapsulation, and if it's not, and I bet you can guess what this is, RPVST plus rapid per VLAN spanning tree plus if you were doing 802.1q as your trunking encapsulation, that is how they referred to it. Because on the command line, when you say spanning tree VLAN 10, 20, right? If you want 10 and 20, you're trying to manipulate things. I apologize. If you were to say, spanning tree mode, you would say rapid PVST. And so that's where this comes from. But then right across from the actual command, the explanation, they use per Vlan rapid spanning tree protocol and PVRST plus. And both of these made it into Cisco documentation. So if you go out and Google Cisco documentation, you will find references to PVRST as well as RPVST. And again, all that happened here is Cisco took what the IEEE standardized and said, that's a great start, and we're going to go ahead and we're going to add our Cisco secret sauce in here. And we're going to allow you to do layer 2 traffic engineering with all of the benefits of the rapid spanning tree protocol. And we're going to call it RPVST or RPVST plus, again, depending on the trunking encapsulation that was being used. And this was absolutely fantastic, right? And so this is why you see RPVST plus or PVRST plus sometimes, but keep in mind, these are synonymous, right? This is just two ways of saying the exact same thing, which is this is Cisco's implementation of the IEEE 802.1W standard. Because back when the original spanning tree came out, there was also known as common spanning tree or CST. Because again, there was a single common instance of spanning tree for the entire topology. And Cisco gave us per VLAN. And that was great, right? But one of the challenges here was the high overhead, right? Because again, you're keeping high overhead. You're keeping an instance of spanning tree per VLAN. And if you've got 100 VLANs or maybe 1,000 VLANs, that may become a burden. Now, on today's switching platforms, I don't believe that this is a true statement, but again, we talk about where we came from as to how we got to where we are, right? And so then the book, our chapter 3, and the chapter 3 was a great, great chapter, really a huge improvement over the last edition of the Scaling Networks Companion Guide. So high overhead because you had a single instance of spanning tree for every VLAN. And we talked about this last night. If I have the topology that I have up top, and I'll do my switches in red here. And remember what we said. How many possible in a well-architected network where we've got our access layer down here, and we've got our distribution layer here, and we've got a layer 2 domain. If this is my root bridge in red, right? This is going to be my designated port. This is going to be my designated port, keeping in mind that all ports on the root bridge are designated ports. And for right now, let's do the same thing that the text did. We're going to assume that we only have VLAN 1. So we're only dealing with one VLAN. But know that even if we had multiple different VLANs on here, right, that this conversation would be the same. So if this is the root bridge for all of the VLANs, and in our case just VLAN 1, then these are my designated ports. So then it becomes clear that, and we'll say that's switch A, and this is going to be switch B and switch C. And we're going to say that the switch name, just like in class, that's the MAC address. It's all A's, it's all B's, it's all C's. So switch C, what would be the root port? Well, it's going to be this port here, because remember, Bpdus are going to be sent, those bridge protocol data units are going to be sent from all of the switches initially. And they're all going to send these Bpdus, and they're all going to be claiming the same thing, is that, hey, I'm the root bridge. And that takes us to that bridge priority, which by default, the bridge priority is 32.768. Whoops, 32.768. And so if these are all defaults with switches or out of the box defaults, and we plug them in just like this, right? And we're going to we'll say that they're dynamic desirable, not dynamic auto, and that we're doing 802.1q as our trunking encapsulation. Cisco switches run by default, not the latest switches, but the earlier switches. So not the 3650 or the 3850 or the 2960, but the earlier switches like a 3560 or a 2950 or a 3550 or a 3750. Those all ran by default the PVST plus. And our PVST, PVST plus, again, depending on the trunking encap, because those did support both of those encapsulations. So we look at this. If this is my root bridge, these are designated ports, so the Bpdus are being sent out, and because this has the lowest MAC address, he's going to win as the root bridge. So he sends out his Bpdus every 2 seconds by default, and switch B gets the Bpdu and says, yep, this guy's the root bridge, and so what's my cost to get there? Well, if these are fast Ethernet links, right, we'll say everything's a fast Ethernet, the cost is 19. Well, it's definitely, that's going to be my root port in red. This is going to be the root port on switch C because it's the closest, and we said closest translates to lowest cost. So the cost of this link is 19. And I said link, technically it's the cost of the port, right? Because the Bpdu comes in, and this is probably a good time for me to grab my Bpdu. Right, I've got this little image here of a Bpdu, right? So these are the fields inside of the Bpdu, and this is what we're talking about, right? This is how this information gets communicated. Is switch A every 2 seconds sends a Bpdu down to C over this link here, and he sends a Bpdu over to B. And inside that Bpdu, you can see there's a lot of information here. And one of the key pieces of information is the root path cost, right here in the center. And I can't draw on it because this program that I use to take these little snaps is always on top. So the root path cost, if you see my cursor moving, that is being communicated. So C gets it, and C looks in here, and again, we're saying that C already knows that, hey, A is the root bridge. He sees the root path cost, and if A is the root bridge, what is his cost to get to the root bridge for A? He is the root bridge. Yeah, his cost is 0 because he's the root bridge. And when we say show spanning tree root, you'll actually see that. So the root path cost is 0. C gets this Bpdu in. He says it's 0, but what is my cost to get to that guy? What is the egress port cost for me? It's 19. And so he adds that 0 plus 19, and he says the cost going that way is 19. And then the same thing happens over here with B. B gets it and says, yeah, it's 19. But then when C and B say, well, what about going that way? Well, it's 19 plus 19. So it's 38 going that direction. And that's why these will be the root ports. Now we get down. So it's very easy when all you're comparing is bridge priority, right? That's a very easy thing to compare. Because if it's all 32.768, right, then we go to the MAC address. So now we're trying to decide, right, every segment, and you'll notice the root bridge has no root ports. And that kind of sounds counterintuitive, but keep this in mind, that Bpdus are not sent via the root port. They're sent via designated ports. And it's away from the root bridge. Again, the root port is facing the root bridge. And across from the designated port, you end up with a root port, right? And so now we get down to this segment here. Who's going to be the designated switch? In other words, who's going to be claiming I'm the designated port for this segment? And which port will be blocked because we have a loop here. So again, B sends a Bpdu to C, and C and B are sending Bpdus back and forth. And what do they examine? Well, they take a look at the cost and they say, yeah, the cost is 38 and my cost is 38 as well. So it comes down to the sender's bridge ID, this field right here. In other words, which sender of the Bpdu has the lower, I apologize. Yeah, I'm sorry. Bridge ID. It's the MAC. It's the lower MAC, but you're going to find it in the sender bridge ID. Which switch has the lower MAC address, right? So B sends onto the segment, and it's all B's for the MAC. C sends onto the segment, and it's all C's. So B has sent the superior Bpdu down to switch C. So C is sending Bpdus to B, and B is sending them to C, and the superior Bpdu with the lower MAC address is B. So B would be my designated port, and then this is my, they used to say and the terminology is always very muddy. It used to be called the non-designated port on that segment, right? They'd call it the non-designated port. But what you'll see is even with Cisco's implementation of PVST and PVST Plus, it says ALTN or alternate. It's an abbreviation for alternate. So they're using the RPVST, or the Rapid Spanning Tree Protocol, port state to describe the port, even though it used to be called something else, and it's not really RPVST. Because again, you probably should not be running PVST or PVST Plus. You should be running RPVST or RPVST Plus, right? Because this is definitely considered, and I'll put this here in big letters, this is legacy. It's about as legacy as it gets. And we'll talk about the standards a little bit more here in a second, but remember that this is legacy because in the newest 802.1d, I want to say 2004, they've removed all reference to spanning tree, to the original spanning tree, the IEEE original 802.1d protocol. It's all about the rapid spanning tree protocol because 802.1w got folded into 802.1d 2004, right? And so as you can, and this is why there's a lot of confusion around spanning tree and the different names and versions and who's what, and we'll look at some output on the Cisco switches where you'll see that Cisco, when you say show spanning tree summary, you're going to see it says IEEE, and it's like, well, what does that mean, right? Why doesn't it say PVST? And we'll talk about that. So back to our topology here. So that becomes the blocking port. Now, we're kind of taking the long way around here, but again, I want to make sure we've got a good understanding. So for green, if this was configured as the root bridge, this would be my designated port. This would be a designated port. And so we go through the same process, right? We know we've elected the root bridge, so now we need to determine what are the port roles. So this is the closest port on switch A facing switch B, so that'll be a designated, I apologize, a root port. That'll be a root port, and that's a terrible R there. Here, let me scratch that out. Sorry. In fact, I think if I do, there we go. Let's get this better here. So this is going to be my root port here. And then on switch C, in this topology, it's kind of obvious, right? It's the closest port to the root bridge. But then we come over here between switch A and switch C. And again, pretty simple, right? A versus C. So this guy becomes the designated port for that segment. And what about here? Yeah, he becomes the blocking port. And so I'm going to change colors one more time. We're going to go to blue. And we're going to say, and again, I want to switch to blue over here. And we talked about this in class last night. You would never make your access layer switch in a topology like this. You would not make the access layer switch, assuming we've got links that are going up here to routers or whatever the case may be. You would never make your access switch the root bridge, right? Not a good idea. So we've got the root bridge here, which means this is a designated port. This is a designated port. This would obviously be the root port for switch B. This will be the root port for switch A. And now, and this is why, right? Because take a look at what's happening here. We're going to be blocking the traffic between the two distribution layer switches on one of these links, right? And which one's it going to be? Who has the superior Bpdu, right? The superior Bpdu, the lower MAC address, the sender's bridge ID. Well, it's going to be A, right? Because A is lower than B. So this becomes the designated port, and that would be the non-designated port, I'll say. It's alternate in rapid spanning tree, and that's what we'll see in the output on the Cisco switch. But the key takeaway here is how many variations, how many different layer 2 topologies can we create? Because we've exhausted all of the different options here. And if you're saying to yourself, well, Travis, it looks like 3, you're absolutely right. That's what it is. It's 3. There are only 3 different topologies that we have here. And so to pull this back to the conversation about the high overhead and the rapid per VLAN spanning tree implementation is, do I really need to have, if I've got 1,000 VLANs, do I actually need 1,000 instances of spanning tree? No. What is the maximum number of topologies that we could have? 3, right? So really what I need is I need some method to allow me to simply go ahead and create instances into which I'm going to place the VLANs. Instead of creating a single instance per VLAN, right? Create one instance, and inside of that instance, think of it as like a box, I can place a series of VLANs so that I limit the instances of spanning tree. And so let's talk about multiple spanning tree, because that is what multiple spanning tree solved, right? Now, again, talk about mass confusion. Cisco called it multiple instance spanning tree protocol at one point. Then I believe it was just MST, and then the standard is MSTP, multiple spanning tree protocol. So we've got 3 different ways to basically say the same thing, multiple spanning tree. And so I'll just use MST, multiple spanning tree. Okay, what did multiple spanning tree do? Well, multiple spanning tree, think of it as 802.1s, even though it has been rolled into the 802.1q, and you're probably saying, well, wait a second, isn't that the trunking protocol? And it is, right? So the 802.1q 2005 standard. And again, you can see where the confusion can come in when someone says 802.1d, 802.1w, 802.1s. Those are the legacy names, right? But those are kind of in the industry, those are really the names that they're most well known by, right? If you're going to refer to a standard. But technically speaking, MST, multiple spanning tree, is 802.1q 2005. Rapid spanning tree protocol is 802.1d 2004. And the original spanning tree protocol was 802.1d 98. But again, it has been completely wiped from this update, the original spanning tree protocol, right? So multiple spanning tree, what does it allow me to do? It allows me to say, I'm going to have a single instance, and we'll say this is instance 1 of multiple spanning tree. And then I can have instance 2. Now, up here, if I had 1,000 VLANs, I had 1,000 instances. But down here, if I have 1,000 VLANs, I can say 500 of those are going to use instance 1. And instance 1 is going to be red. So that would be the root bridge for instance 1. And then I can associate these 500 VLANs with instance 2. And we can say that instance 2 would be, and it's definitely not going to be the blue, instance 2 would be green, right? So it would be, the root bridge for instance 2 would be switch B, because that's all that's required. And we still achieve the overall goal, which is load balancing between these two links and these two distribution layer switches at layer 2. And remember in class I commented, so here's kind of, the dirty little secret is multiple spanning tree is really running rapid spanning tree protocol behind the curtain. This is the spanning tree protocol that's really running under multiple spanning tree. It is rapid spanning tree protocol. So you can think of multiple spanning tree as kind of like a wrapper, right, that allows us to create instances, because we know the maximum number of instances in a well-designed topology for spanning tree is going to be 3. And by well-designed, I mean that, right? This topology here, it's going to be 3. And so with 2 instances, I have achieved load balancing, and instead of having 1,000 instances of spanning tree running, I've got 2. And so MST, which is a little more difficult to configure, is still the optimal approach to configuring and architecting a layer 2 domain in which you want to achieve load balancing for a large number of VLANs. And so hopefully this has kind of pulled together not only our discussion from Tuesday evening, right, but your work on these different packet tracer activities, because this is what spanning tree is all about, right? It's all about stopping loops at layer 2, providing loop freedom, allowing you with the Cisco implementation and then with the multiple spanning tree implementation to achieve layer 2 traffic engineering and to balance that traffic out while getting all of the advantages, right, of the rapid spanning tree protocol that were implemented when it matured from the original 802.1d 1998 standard. I wanted to make sure that I covered this because this causes tons of confusion, right? When you're trying to figure out, what are all these acronyms and what do the standards relate to? And that is how we got from Radia Perlman to last Tuesday evening. Okay, so I am going to leave that there. In fact, I will screenshot that and upload that to our Canvas classroom. But let's transition back here to the activity. All right, so we're going to be configuring PVST plus Portfast and Bpdu guard. So refer to the topology diagram. We see it up there at the top, and this is a very straightforward activity. So first, we're going to configure the VLAN. So it says create VLAN. So let's just do this in order, and I will definitely MC this as we continue to deal with the activities where, yes, the type is extremely small. So I'm in user exec at the greater than prompt. I'm going to type enable to get into privilege exec from user exec. We're going to go into global config, and I'm going to create the VLANs. Now, here's how you would create VLAN 10, 20, 30, 40, 50, 60, 70, 80, and 99 in the real world. And in fact, let me pull up a real Cisco switch, and this is one here that was just configured. So let's use this one here. We're going to terminate the auto install. So I'm on this switch. This is a 3550. So this is one of those older switches that was dynamic desirable by default. In fact, if I say show run, let's see if it shows it in the, switch port mode dynamic desirable, right? This is different from what we see in class on the 3560 V2 and the 2960s, where you don't see anything here, right? Because it's the default. But with the 3550s, the older switch, that is the default. And it was a security issue because you don't want someone to accidentally plug two switches together and then have desirable and desirable, and that will negotiate a trunk link. And you don't want that, right? We don't want that. So that's why Cisco switched it to dynamic auto. So here we are on this switch. So here's how you would do this in the real world. I would say VLAN 10, VLAN 10, comma, 20, comma, 30, comma, 40, comma. You kind of get the idea, right? Comma, 60, comma, 70, comma, 80, comma, 99, and I hit enter, and you see that it works great. Now, with Packet Tracer, we're going to have to do a little legwork here, because if I say VLAN 10, comma, 20, comma, 30, and I'm going to stop right there, and I hit enter, you see it says invalid input detected. So you guessed it, we're going to need to do VLAN 10, VLAN 20, VLAN 30, VLAN 40. And this is okay though, because right, muscle memory, it's going to get you configuring these VLANs 70, VLAN 80, VLAN 90. So you're definitely getting some practice here with the creating VLANs with the VLAN command. So I say end, and how do we confirm that? Show VLAN brief. Right, and there I see VLAN 10, 20, 30, 40, 50, 60, 70, 80, and 99. Now, it was great doing it once, and you think, I got some good practice there. Well, guess what? We get the bonus lab. We're going to have to do this on switch 2, right? And let's go from user exec to privilege exec into global config, VLAN 10, VLAN 20, VLAN 30, oops, not 309, no, VLAN 309, VLAN, and this is why it's better to do it on a single line. VLAN 30, VLAN 40, VLAN 50, VLAN 60, 70, 80, and then 99. It was catching up with me there. So we'll type end, and we'll say show VLAN brief. And there we go, 10, 20, 30, 40, 50, 60, 70, 80, and 99. And one last time here. Let's go ahead and pull the CLI up, and we'll transition from user exec to privilege exec with the enable command into global config with configure terminal, VLAN 10, VLAN 20, VLAN 30, VLAN 40, VLAN 50, VLAN 60, VLAN 70, VLAN 80, VLAN 99. Now on Tuesday, if I ask you the command to create a VLAN, definitely something you should be able to answer. So show VLAN brief, 10, 20, 30, 40, 50, 60, 70, 80, and 99. And you can see over here in the lower right-hand corner, we've got 27 out of 100 going for us right now. So we've created the VLANs, assigned VLANs to switch ports. Well, there's only 3 switch ports that we're working with here. FA06 on switch 1, FA018 on switch 2, and FA011 on switch 3. So we're on switch 3. We might as well take advantage of things here. We'll get back into global config with configure terminal, interface fast Ethernet 011, and we're going to say switch port mode access, switch port access VLAN, and on switch 3 fast Ethernet 011 is VLAN 10. Now, we made it an access port. Why did we do that? Well, because again, FA011 on switch 3, we can clearly see that the end host is a PC. So what other commands would I want to run here? And in fact, I believe that we are asked to do this. Yeah, Portfast, configure Portfast and Bpdu guard. Well, where would we configure that? We would configure that on the port, on the switch that faces a host, something that we know is not going to be a switch. And so that's why we say spanning tree Portfast. And what does Portfast do? Portfast enables the port to go from down, right? If it's in a down state and we plug something in, it allows that port to skip the listening and learning phases of spanning tree of legacy original 802.1d, which is PVST plus. It allows us to skip listening and learning and transitions the port immediately to the forwarding state. And for a host, that makes sense. And we talked about for DHCP servers, right, where that may be an issue if you're running PVST plus, and the DHCP server or the client even goes to make a request, and then it just kind of waits, and then you get that APIPA address, right? That link local IPv4 169.254. So that could be an issue. Maybe it's not an issue, but again, it's having to sit there and wait, 30 to 45 seconds for the port to come online to transition from listening to learning. You get the forwarding delay, right? That takes time. Portfast skips all of that, but we need to protect ourselves against someone plugging another switch in, because that could create a loop, because we're saying skip the listening and learning phases of spanning tree. So we're not actually going to be participating in spanning tree per se, right, as we normally would. So we need to make sure we protect ourselves, and to do that we say spanning tree, I'm sorry, it's going to be Portfast, is it BP, Bpdu, or no, spanning tree Bpdu guard, Bpdu guard, and enable. There we go. So spanning tree Bpdu guard enable. And Bpdu guard enable does one very, very important task. If that port that I just configured Bpdu guard on, if that port fast Ethernet 011 had a Bpdu, and I guess let's pull my little snippet here up. If a Bpdu, for whatever reason, came in from PC1 over here to FA011 on switch 3, Bpdu guard will air disable and shut down, not administratively shut down, but air disable and basically cut that port off. And it will require manual intervention to bring that port back up. Because if a Bpdu came in, what type of a node generates Bpdus? A switch, right? So if a Bpdu showed up here and we had Portfast and Bpdu guard configured, what we're saying is we don't want a switch, and we're not anticipating that a switch is going to show up on that port. And if it does, we need to protect ourselves against loops at layer 2. Spanning tree takes care of that. And again, these were part of the Cisco spanning tree toolkit, right? Portfast and Bpdu guard. So we've got that on. We've taken care of switch 3. Let's do the same for switch 2, but it's going to be a different port here. So configure terminal, and we go into interface fast Ethernet 018. And this is where we're going. And you know what I forgot to do there on switch 3, right? As I just looked up here, are we done? Well, we're certainly not done, because we've got orange here, we've got red here. So I forgot to say no shut. And take a look. It transitioned immediately to green, right? Which is what we want. In fact, with switch 2, what if I do this? No shut. Did the switch port transition to green immediately? And the answer is no, right? You can see it did now, right? And that's way quicker than it would do on a regular Cisco switch. But the reason it didn't is because Packet Tracer is doing its pseudo listening and learning before it transitions to the forwarding state. So we up the port, but we're going to say spanning tree Portfast, and then we're going to say spanning tree Bpdu guard enable. And now let's go do the same thing here on switch 1. We'll go from privilege exec to global config with configure terminal interface fast Ethernet 06, where we're going to say spanning tree Portfast, and then spanning tree Bpdu guard enable, and then, oh, and I forgot, I guess on switch 2, I forgot to say switch port mode access and switch port access VLAN. Switch 2 is VLAN 20, and switch 1 is going to end up being switch port mode access and switch port access VLAN, no, 30. Going to be careful there. Switch port access VLAN 30, and then we're going to give it the no shut, and it's going to go green, or should go green immediately. And of course, do show run. Let's see. Let's make sure fast Ethernet 06, and we've got Bpdu guard on there, and Portfast, switch port mode access, and VLAN 30 switch 1. That's correct. So again, I'll say that this is something with Packet Tracer. We saw it work over here. That should be working right there, and it's not. There we go. Okay, so again, I'm blaming it on Packet Tracer because it should light up right away, right? Because we're skipping, listening, and learning. Okay, so we've got the VLANs configured on all the switches. We've got the host ports configured on all of the switches. Now, we're going to go ahead and assign the trunks. And hold on one second here. Port assignments are listed in the table beginning with the activity. Show VLAN brief. Use the appropriate command. Oh, okay, so fast Ethernet 01 through 04 on all of the switches. Those are going to be our trunk ports. And we are going to assign those trunk ports to the native VLAN 99. Configure the management interface on all three switches with an address, which is listed up there, 172.31.99, 2, and 3, and verify that they are correctly configured. All right, so we're on switch 1, so we might as well start here. Let's go into interface range, fast Ethernet 01 through 4. And we're going to say no shut, even though they look like they're up. I like to issue that no shut just to make sure. And we're going to say switch port. And does it ask for? Yeah, so this is one of those instances where if I say do show interface fast Ethernet 01 switch port, you can see here that what is the trunking encapsulation? It's .1Q. That's the administrative. That's our default trunking encapsulation. In fact, if I was to say switch port trunk encap, look at that. It doesn't even give me that command to change the switch port trunk encapsulation .1Q. Now, could be because Packet Tracer is skimming it down. On a legacy switch, like the 3550 we have here, if I go into global config and say do show IP interface brief, and what are my interfaces? Good, fast Ethernet. So if I go into interface fast Ethernet 01 and I say switch port trunk encap and question mark, take a look. There's ISL, right? Now, I validated that you don't see this on the 3850 and the 3650. Because again, ISL is deprecated, it's legacy, right? And there was even a negotiate option back in the day. But .1Q is the default, which is why it's not even an option here on what is a simulated do show version. This is simulated 2960, it should be. There it is, 2960. All right, so we'll say switch port, and it wants us to configure these as trunks because you should have also seen that what is the default, right? Take a look. It says static access, right? You see that where it says static access here? And that's interesting because what did we see? We saw dynamic auto as the administrative mode by default on the 3560 V2s and the 2960s, but then it negotiates to access because auto and auto is not going to successfully negotiate a trunk, right? So for some reason here, Packet Tracer has this static access. So we're going to go ahead and say switch port mode trunk or just switch port MT. Now, I've hard-coded it as a trunk port. So I don't need DTP to be running. So this is a Cisco best practice. If I hard-code it as a trunk, the best practice is turn off switch port or turn off the dynamic trunking protocol with switch port no negotiate. So I'm going to say switch port no negotiate. Then I need to say switch port trunk native VLAN, and our native VLAN is 99, right? Now, what do we see right away? We get a native VLAN mismatch, and this is to be expected because we've changed the native VLAN on both sides, or I should say on one side of these links that are going to be trunk links. And you'll notice that we're now getting switch 2 and switch 3 are complaining, right? Because we've changed all of switch 1's trunk ports. Now, do show interface trunk. What do you expect to see right now? Well, we see that 1, 2, 3, and 4, these are all in trunking mode, right? And it's on because I've hard-coded it on. And a quick sidebar, this is a very common and popular thing to see, and a number of you ran into this, and we talked about this on Tuesday evening on the 3560, right? On the 3560, when you said, and I'll make this a 2960 here, on the 3560, when you said switch port mode trunk, right? It kicked back that error telling you, yeah, you can't hard code this as a trunk port when it's set to auto, right? And it forces you to set the encapsulation. And I can't remember the exact syntax of the error, but you'll remember that you got that error when you tried to say switch port mode trunk. And it wasn't until you said switch port trunk encapsulation .1q that it would then let you say switch port mode trunk. And here's the reason for that. Remember the 3550 we looked at with the default of dynamic desirable, right? Which means it's going to actively try to negotiate a trunk. The newer switches, it's dynamic auto, which means it's not attempting to negotiate a trunk. And that's why you see that auto output in the error message. But the reason you can't say switch port mode trunk when the default is auto is because by saying switch port mode trunk, you are saying that I am hard coding this as a switch, as a trunk port. And on the 3560 platform, remember the 3560 does not default out to 802.1q. You have a choice on the 3560 of ISL or 802.1q. And so the reason you see that error message pop up when you say switch port mode trunk on the 3560 and not on the 2960 is because the 3560 says, hey, I can't let you convert that port. I can't let you hard code that port as a trunk port until you tell me what you're going to hard code the encapsulation on that trunk port as, right? And hopefully that makes sense. Again, when it's auto, if it's going to negotiate it, the trunking encapsulation, that's fine. It'll try to negotiate ISL. It'll try to negotiate 802.1q. If it can't do that, it falls back to an access port. But when you say switch port mode trunk, you're not telling it what is it negotiating to. You have to hard code the encapsulation in there because you're hard coding the port saying, yeah, no, I don't want you to negotiate anything for me. You are a trunk port. And so the switch in return is going to look at you and say, that's great. If I'm a trunk port, then you tell me what my encapsulation is because you're telling me I'm not allowed to negotiate that anymore. By saying switch port mode trunk, you're saying that there is no more negotiation that's taking place, right? So that's why you see that error. And that's why you don't see it on the 2960 because there is no need to hard code it because the default is always 802.1q and only 802.1q. That is the only choice, which is why when you say switch port mode trunk with the 2960s, you don't get that error message because you say switch port mode trunk, you say, hey, 2960, that port is going to be hard coded as a switch port. You're not allowed to negotiate the trunking protocol. I'm hard coding you down. And the 2960 says, that's totally cool. And you want to know why? Because I can't negotiate my encapsulation. I'm 802.1q or bust. In other words, it's 802.1q for me or nothing. And so that's why you don't see that error on the 2960. And that's very important because that becomes very, very confusing for a lot of learners as to why on the 3560 do I get that error when I say switch port mode trunk, and why does it go away after I say switch port trunk encap.1q. All right, so let's clear the screen here and let's come back. So you can see we've got errors galore here, right? Native Vlan mismatch, which is the Vlan tag that a trunk port will put on received frames that show up with no Vlan tag. All right, so we did switch one. Let's knock, whoops, sorry. Let's do our SVI, right? That switch virtual interface. It's going to give us connectivity to the switch on VLAN 99, and the IP address is 172.31.99.1. It's a /24. And I don't have to say no shut. I always do it just out of habit. And now let's say do show IP interface brief. And we can see VLAN 99 is up. I'm going to do a quick write mem here. And let's transition to switch 2. Now, take a look. Right? It's like Christmas in September right now here. Right? Because, boy, we've got native VLAN mismatches everywhere. We've got all kinds of issues. Let's see if we can't settle things down a bit here. So we'll come over to switch 2. We'll go from user exec to privilege exec into global config. And we are doing, I know we've got that interface. Let's take care of the SVI first. Interface VLAN 99. And we're going to say IP address 172.31.99.2, 255, 255, 255.0. No shut, even though it's up automatically. And now let's get into interface range, fast Ethernet 0, 1 through 4. Right? And I'm going to say switch port, mode, trunk. So it changes them all to trunks, right? But we've still got that, and you can see what happens now. Now we get a spanning tree error, received PVID, VLAN ID error. It's inconsistent, right? The native VLANs don't match, right? There's a mismatch here. So let's go ahead and take care of that as well. So we said switch port mode trunk, switch port trunk, native VLAN 99. And you can see here, right, that the orange ports have kind of gone away. The consistency between 1 and 2 has been restored. I'm also going to go ahead and throw that no negotiate, not required, but best practice, so good practice to drop it in there. Another good practice would be to limit the VLANs that are allowed on the trunk link, but since there's so many, I'm just going to leave that to the side for right now. So do show run. And there's what our first 4 ports look like that are our trunk ports. So do show interface trunk. And there we go. And so again, we're looking at 1020, and seems we're missing a couple here. And of course, we're probably missing them. Why? Yeah, because we've got issues with the trunk links between 2 and 3 aren't configured, and 1 and 3, right? This is broken here, right? Because 3 is still all static access ports. So let's go ahead and type end, and we'll give this a write mem, and we'll pull up switch 3, and we'll go from user exec into privilege exec with the enable command, configure terminal into global config, interface VLAN 99, IP address 172.31.99.3. It's a /24, so dotted decimal 255, 255, 255.0. And then we're going to go into interface range, fast Ethernet 0, 1 through 4, switch port mode trunk, right? And take a look at that. We've resolved all kinds of inconsistencies, and now spanning tree is converging here because it's trying to determine which links to forward on. What are the root ports going to be? What are the designated ports going to be? What are the blocking ports going to be? And so it's working through all of that right now. And do show run. Let me actually make sure that we get, so switch port trunk native VLAN 99, switch port no negotiate. And let me take a look here real quickly at the instructions. Appropriate commands to configure FA as a switch port is assigned trunk to the native VLAN 99. We did that. Management interface, we got that. So let's test connectivity now. So I'll do a quick write mem, and let's say ping 172.31.99.1. And it's going to have to ARP out undoubtedly, so we'll probably drop 2, and there we go. And then we've got connectivity. Can I ping 172.31.99.2, switch 2? And I can. So we've got connectivity. That's fantastic. Now we get into configuring spanning tree. And so what I'm going to do here is, not going to do that just yet, but I'm going to give us a little more room to work with. So we've got these trunk ports. So what if I say show spanning tree summary, right? So when you say show spanning tree summary, take a look at the default mode here on this 2960. Right? And again, this is packet tracer. Your mileage may vary with the real hardware that you're working on, but it says switch is in rapid PVST mode, right? And so to go back to the confusion with the names, the RPVST and the PVRST, if I'm on a real Cisco switch and I say spanning tree VLAN 10, I'm sorry, not spanning tree VLAN 10, spanning tree mode, take a look here, and this is where all the confusion arose between those. Remember, I showed you those 4 different ways here to identify Cisco's implementation of the rapid spanning tree protocol. We come back here, take a look. Rapid PVST. Okay, so rapid PVST, RPVST. And then you would have RPVST plus if you were 802.1q. And then the description of it is per VLAN rapid spanning tree protocol. So per VLAN rapid spanning tree protocol, or PVRST plus. And so that is the source of these 2 very, very confusing ways of saying the exact same thing, is that we are simply using Cisco's special sauce implementation of the 802.1W rapid spanning tree, RSTP, rapid spanning tree protocol, right? And so you can clearly see why there was so much confusion. And again, you will see inconsistencies in documentation at Cisco, and again, older documentation. Newer documentation doesn't have this issue, but older documentation, there were representations of both of those. So let me clear that, and let's get back to the command line here. So you can see that it says we're running the rapid PVST mode. In other words, RPVST plus is what we're doing because our trunks are encapped with 802.1q. So what are we being asked to do here? So we want to configure the spanning tree mode. And again, this is an activity that's showing us how to do these things. You would not in a real environment, you would not be rolling back from RPVST plus. You would not be rolling back to PVST plus. Probably not something you're going to be doing, right? You would be going the other direction. So basically we say spanning tree mode, and then if I do a question mark, you can see right there, PVST. And that's what it's asking for. So I'm going to come to switch 2. We're going to do the same thing. We're going to type configure terminal to get into global config, spanning tree mode PVST. And then on switch 1, let's do the same thing. We'll say conf T for configure terminal, spanning tree mode PVST, right? And that's kind of moving the points along. And let me make sure. So the idea behind this is we're going to be doing load balancing, right? And these activities are phenomenal. I know I point out little snafus here and there, but the activities for V6 have really, really improved. I mean, this is a real world scenario right here with an access layer switch, switch 2. You've got 2 distro layer switches up here, switch 3 and switch 1. And we're doing layer 2 traffic engineering right now by load balancing the VLAN traffic. And how are we going to do that? Well, it says configure switch 1 to be the primary route for VLANs 1, 10, 30, 50, and 70. So what that means is if switch 2 down here, let's say switch 2 had, 200 clients and they are in these VLANs that we've configured, 10, 20, 30, 40, 50, 60, 70, and 80, right? And we want to share the load. We want to spread the load around, right? So on switch 1, and this is switch 1 right here, how would we do that? Well, we would say spanning tree, and now I list out the VLANs that I'm interested in dealing with here on switch 1. 1, 10, 30, well, it's the odds. 1, 10, 30, 50, and 70. Although, interesting, it's all the odds except, well, I guess it's the first digit is odd. They're all even. The first digits are all odd, and then 99 ends up on the other side. So we'll go with it. 1, 10, 30, 50, and 70. And now I get a choice here. And this is where we talked about the macro versus hard coding it, right? Now, best practice is I say spanning tree, VLAN, and I list my VLANs out, priority 0. If it's going to be the root bridge, I'm setting the priority to 0, right? And let me make sure that they don't want to. So they say primary root. So now I don't know if they're anticipating, I don't know which command they're looking for. So let's do this. I'll say priority 0, and let's see, do they honor that by awarding us with any points? Or were they anticipating that I was going to use the priority, because that makes switch 1 the root bridge for VLANs 1, 10, 30, 50, 70, right? But Packet Tracer didn't like that. So we're going to pull that out, and we're going to say do show run, and I'm going to make sure that that is not in there. And we're going to go back and we're going to run it the other way. So I'm going to say, whoops, let's do it here. Spanning tree, VLAN 130, 50, 70, priority, I'm sorry, not priority, root, and primary, right? That's probably what it's looking for, since it didn't like us hard coding it. And that is the macro, because remember, what that does is that changes the priority for those VLANs. So if I say do show spanning tree, we can see it changes the priority to 25. Where are we at here? And let's see, VLAN 30. And I may have to punch this up on, I'll punch it up on one of the neighbor switches where we'll get a better look at it. But it's interesting. I'm hoping that I didn't tweak Packet Tracer, because we did not get any points for that either. But let's configure this out and see what happens. So we'll go to switch 3, and I'm going to say spanning tree VLAN, and this is going to be the primary for VLANs 20, 40, 60, 80, and 99, and root primary, right? So we've got that sorted out, and then configure switch 2 to be the secondary for all VLANs. So I come over to switch 2, and you can see we did get some points for switch 3. So it's going to be spanning tree, VLAN, and again, we got to list them all out here. So 10, 20, and at least we can get them all in one. 30, 40, and 50, and 60, and 70, and 80, and 99, root secondary. So let me go ahead and do a quick write mem here. We'll save that off. I say show spanning tree. And when you look at this, you can see that VLAN 1, now we know the primary root bridge for VLAN 1 is switch 1. And we said we used the macro there. And so what did it do, right? It dropped the priority down. You can see this is the bridge ID for, this is the local switches information. This is the root bridge switch information. So when we said primary, it dropped it down to 24576. I believe I've got that number right. It dropped it to 24576. And when we said secondary on this switch 2 said, okay, you're using the macro, right? And because there's two ways to do it. If I said priority, that is hard coding it. That is not the macro. When you say root primary or root secondary, that's the macro. And the reason we refer to it as a macro is because you'll notice it sets the priority for you to this pre-established, I shouldn't say pre-established value, but to a value. It's going to check and see, hey, who's got the lowest priority? And then it's going to bump itself up, keeping with that spanning tree. You know, we talk about I've got these images over here. Let me wheel them out real quick. So remember, the priority is going to be in multiples of 4096. Right? And so what that macro does, when I said root secondary here on router 2, you can see it says 28673. If I was to take 28673, Let's pull the calculator up here because there's no way I'm going to be doing this in my head. And let's validate that this is actually true, right? So 28673, and the calculator is definitely taking its time. And here's another way you can do that. And this is the quick way. If you're in the command line, the quick and dirty way is do this. Say spanning tree VLAN 1 priority, and then put in a bogus number. And actually, let's make it less bogus than that. Something small and bogus, and this will show you what the valid values are, right? So when I say root primary, it checks to see what the other values are in the environment from the other BPDUs, from the other switches, and if everything is the default, 32768, the bridge or the switch on which you ran the spanning tree VLAN root primary command will drop its priority to 24576. That's why we call it a macro, because you're not typing in priority 24576. You're just saying root primary. And then it oops, sorry, I didn't want that. And then it auto-magically sets it to 24576. When you say root secondary, it auto-magically looks, and then it saw what? It saw that there were 2 root bridges for different sets of VLANs that it was also being configured for, and we said root secondary, so it set it to 28672. And that is why in the calculator now it wants to work. And that is why we see 28673, because remember, the system extension ID. And so a brief note on that. Remember, it holds 12 bits. 2 to the 12 is 4096. And that system extension ID is simply the VLAN number, right? So when we're coming up with that bridge, the bridge ID, right, you've got your priority, the bridge priority, the system extension ID for whatever the VLAN is that we're working with, right, or the VLANs that we're working with, and the system ID or the MAC address. And that makes up the bridge ID, those 3 fields. Now you'll notice up here this original 802.1d98. Take a look here. The priority, all 16 bits or all 2 bytes went toward the priority. But the problem was, in order to differentiate things, they used MAC addresses. And so then when you started to get hundreds of VLANs, you had to use hundreds of MAC addresses because it was the MAC addresses that were being used to identify the separation of the different VLANs, I should say. And that was the original bridge ID format. So what they did was they took the high order, right, the leftmost 4 bits over here, and said, those are going to be the priority bits, and we only need 4, and we'll do it in multiples of 4096, because again, we're not using all 16 bits, and 12 bits, because we've got 4,000, 0 to 4095, so 4,096 possible values, of which 1 to 4094 are usable. So we've got these 12 bits here. Those are going to represent the VLAN. So it's called MAC address reduction, right? That system extension ID, and you see that on switches. If I were to say do show run, remember when you see that, there it is, spanning tree extended system ID. Because on some really old equipment, you could say no spanning tree, and we'll say copy and paste there. Yeah, so it's not going to let me do it on the 3550. This platform, mandatory. But on older switches, right, you could remove that if you were okay with using MAC addresses, right? And you wanted that legacy feel to things, but you can't do it. And again, realistically, it doesn't make sense. You're not going to do that. But I wanted to cover why it is that we have that system extension ID. And you see that sys ID extension right there, right? So it simply adds that to the priority. It takes the VLAN number, adds it to the priority, and that is how we end up with that value. So we are at 94 points here. We've made that show spanning tree. We did Portfast, we did Bpdu, guard on the switches, and we are 6 points away. So let me, oh, did we not, you know what I didn't do? I'm sorry, we're 6 points away. I think we've got one more switch that we're working with here. So let's make sure, if I say show spanning tree, I'm sorry, show spanning tree summary, show spanning tree summary, and yeah, so we are, okay, there it is. PVST mode, right? It says switches in PVST mode. Now, this is what's interesting. On actual Cisco switches, it will say IEEE in some cases, which simply means, and am I missing that in here? No, I'm not missing that in there, am I? Okay, yeah, it'll say IEEE in there. So we've set the mode. I believe we've got switch 1 yet to configure. Oh, there it is right there. Spanning tree enabled protocol. I apologize. It was the show spanning tree where it shows the protocol is IEEE. So let's go ahead and say show run. Okay, we've got our mode is PVST. We're good there. Over here, do show run. It looks good there. And then here we'll say show run. And PVST, everything looks good. So let's take a quick peek. It's probably something simple that I ran by. And for switch 1, that says the priority for 10. And did it not take? And that's it, right? Yeah, so it didn't like the priority on switch 1, but I was pretty sure we configured that. Let's take another look at switch 1 here. And maybe spanning, oh, so it kept that command. And I'm wondering if that is going to cause an issue here, if it's not going to let me finish this out with that command in there. And let's say write mem. So we did enter the right command, but it didn't like it. So you see it's not there right now, right? So I'm going to do this. I'm going to reload switch 1. And just to make sure we don't have that same issue. So we've got a lot of red ports up there right now, and that's okay. We're not going to have to wait long. But yeah, me putting in and demonstrating using the priority option looks like it may have caused some issues. So what we want, and so that I don't have to, it looks like I am going to have to rerun that command. I'm going to grab that right there. So 110, let me reread. 110, 30, 50, 70 on switch 1. Is that right? That's got to be right. Yeah, that is correct. Yeah. All right, so let's try it again. We're going to say spanning tree, and then I've got the VLANs listed there. And then we're going to say root, primary. And does that get us? I think that got us over. Yeah, and that's one of the hazards of packet tracer duty is when you try to demonstrate some other things, when you go to remove configuration, it doesn't necessarily do what you expect it to do. All right, so if I was to say on switch 1, show spanning tree, if I get that in there, we can see here that for VLAN 1, right, it shows me the root ID. So who's the root bridge? Well, all I need to do is look at the MAC address and compare those, and I can see I'm the root bridge. Now, there's another command, show spanning tree root, which I can almost guarantee is not going to work on here. Show spanning tree root. Yeah, I didn't think so. So, and this is one of my go-to commands when I'm working with spanning tree, and I believe there's some spanning tree that should be here. So show spanning tree root. And that is the command that I love the most, right? Because it shows me the VLANs that are configured. It shows me the root ID or the bridge ID. There is the priority, and you can see it's 32769, 32770 because you have to add in that system ID extension for the VLAN, and then it shows me the MAC address of the root bridge. So very quickly off of this switch, DLSW01, I can see that for VLAN 2, This is the MAC address of the root bridge, and I can tell right now that I am not the root bridge because my cost to get to the root bridge is 19, which means I'm a single fast Ethernet interface hop away from the root bridge. And then we get our timers. The Bpdu hello time. Remember, when we talked about spanning tree initially, it's every 2 seconds, and only the root bridge, and I hope I said this earlier. If I didn't, I'm going to say it now. Only the root bridge for the VLAN is sending the Bpdus. And remember, it's sending them as it's only the root bridge, right? Remember, root ports do not forward Bpdus. It's the designated ports. Remember, D, designated, downstream facing. The designated ports are forwarding the Bpdus along. And then we've got our max age, and this is sort of, think of it as like the, when we start to talk about OSPF and EIGRP, think of that as the hello timer, and this is the dead timer, right? So if I miss 10 Bpdus, then that tells me there's probably something not right here, right? And so that's that max age timer, and that's when it'll expire the Bpdu, that superior Bpdu that it had received, and it kept on its designated port. It caches that Bpdu, and it's going to hold it for 20 seconds. If it doesn't hear anything, it's going to hold it for 20 seconds, and then it's going to punt it. And then it's going to try to find a superior Bpdu. And then we've got our forwarding delay. How long are we waiting to go from learning to forwarding? And then out which port can I get to the root bridge? And so again, show spanning tree root is a great command. Show spanning tree summary here. And you can see switches in PVST mode. And that tells me right there that I'm running the Cisco implementation of the legacy 802.1D 1998 IEEE standard. And again, when you do the show spanning tree, it says spanning tree enabled protocol IEEE. Well, remember, this is super misleading, right? Because it's not the IEEE's standard version. It's Cisco's adaptation of that standard version. So very different, right? Very, very different than saying, oh yeah, it's running the standard version 802.1, the original 802.1D 1998. It's not, right? It's Cisco's adaptation of that standard version of spanning tree. And in fact, if I were to say, here's what it would show if I go into global, get into global config and say spanning tree VLAN 1-4094. I always want to do the VLAN, spanning tree mode, and change it to rapid PVST, and now say do show spanning tree. Take a look. Again, right, it's kind of misleading, right? Because this is not the standard RSTP. This is Cisco's adaptation. But you see the actual Cisco adaptation when you say show spanning tree summary. Because if I said do show spanning tree summary, we would see what we saw on the other side. Rapid PVST mode. Yeah, because that's what this is, right? That's what this is. And if we're doing 802.1q trunking, technically it's RPVST plus. All right, well, I think this is a good stopping point. Really wanted to cover the fundamentals and the history of spanning tree before we dove into this activity to kind of bring things forward and explain why you're going to be seeing some of the things that you see in the output of these spanning tree commands. All right, well, thank you guys so much for watching. The next video is going to be up this weekend. It's going to be on the rapid per VLAN spanning tree plus, right? And it is different than this version here, and we'll see that it converges quicker because of something we call proposal and agreement. And we don't go deep dive into proposal and agreement, but definitely we're going to talk about it. It's more of a CCNA topic to go a little deeper into what's taking place there, but that's what allows rapid, right, that R, rapid per VLAN spanning tree plus to converge quicker than the legacy PVST plus. All right. Thank you guys so much for watching. I hope this has clarified things for you in terms of spanning tree. I will see you all on Tuesday night. Have a great night.